Hi, I'm Tyson Franklin, and welcome to this week's episode of the Podiatry Legends podcast. Podcast designed to help you feel, see, and think differently about the podiatry profession. With me today, it's Kieran Carew. Now, he was back on, we worked out July 2020, it was episode 93. And back then, the episode was titled Pathology-Based Orthotics. Today, we are going to be talking about 3D printed orthotics, because Kieran has his own 3D printing business, Fit4. He's been doing this since 2019, saving clinics with revenue and control over the orthotic turnaround. So Kieran, it's great to have you on here. I bumped into you at the 2025 Foot and Ankle Show.
That's right, yeah. It's been a while, Tyson, since we spoke originally. It was, as I said, 2020. So a lot has evolved since then.
Yeah, and when I saw you at the Foot and Ankle Show and I saw you had your own 3D printers there, and I've got coaching clients in Australia and overseas, and everybody is talking about 3D printing at the moment. Because I know you and I know you have your own 3D printer, I thought I'm going to get you on here to talk about this whole process. You can explain what you've done, your journey of putting it all together, and hey, yours might end up being the best one in the world. Then everybody can get it from you. And I'm not being paid to say that. So I just thought I'd point that out.
Excellent. Thank you, Tyson. I suppose, too, when we originally spoke, Tyson, back in 2020, we had just embarked on the research for developing the 3D printing system to go into clinics. And obviously, when the pandemic hit, it was a bad thing for everyone, but it was pretty good for us because it gave us time to actually work on the 3D printing system. And at the time, we were sponsored and funded by Innovate UK.
Okay.
And Innovate UK teamed us up with different engineering colleges and universities in order to do the research and development. So along the way, we have tested many printers, many FDM printers, I should say, that would work best in the clinics. We've gone through the development process of our softwares and things. And then we went through clinical trials. And what I was saying to some of our colleagues, I mentioned to you earlier before we jumped on there, we had a journey of learning ourselves because we took it coming from the engineering background that this was going to just operate quite easily inside in the clinic and there's going to be no issues. But what we actually did was we brought two different worlds together, the engineering world and the medical world. And when you often put two worlds together, little cracks and issues appear up because we took it from our side, very easy to operate printers, very easy to design orthotics. But unfortunately, a lot of practitioners didn't even know what a 3D printer was. So when we went out there and we started supplying printers to clinics, the earlier printers had more kind of input required from the practitioner. They needed to be manually calibrated. Now, for our team, that is very easy. They have more control over what they're doing. But we found in some clinics, the clinics struggled with the calibration. And if you get poor calibration, it ends up with a very poor quality orthosis.
When you're talking about the calibration side of things, you're meaning it has to be it has to know where the start point is to begin. Because when I used to have milling machines where we put the block of EVA material in there and to get milled out, and we had to go through the same process when we were changing drill bits if something broke or something happened. We had to calibrate it, and sometimes it was easy and sometimes it wasn't.
That is exactly what it is. And you're also looking at the distance of the nozzle where the filament, the materials come out, had to be a certain distance from the print bed. So it was quite a challenge for some practitioners because practitioners, some of them had in their mind, I just plug in the printer, hit print, walk away, come back and the orthotic is there.
And that's the way it should be, yeah.
And that wasn't the case in the early days.
Yeah.
So as technology evolved, it has now gone to the stage where the printers that we have are pretty much plug and play. So we formed a partnership with a company called Podiatry. And Podiatry are a global manufacturer of 3D printers. So they do a large range. So basically we gave them our wish list, and our wish list was where we took down comments from practitioners that we were working with, what they would like to see as improvements. And we gave it to this company and said, look, can you put this into your printer and see if you can improve it for us? So they developed a printer then with us, which is called Branded. And basically we have auto calibration, and pretty much the feedback we're getting from clinics now that we have the printers with is that the printer is pretty much plug and play. So that then led us to the next side, CAD designing.
Yeah.
So when it comes to designing an orthotic, Obviously, a lot of practitioners were trained in the manual way, draping a cast, vacuum forming, or often grinding. So when you're visualizing something on a computer screen and doing 3D CAD design, it can be different. So there was a learning involved with that as well. And what you find even at Tyson is with different softwares. Some softwares are made so basic, they're modular based. So it's for ease of operation. But the problem is you're often getting more of a library type of orthotic.
Mm.
Whereas if you use a proper CAD software, yes, there's learning involved, but it does give you complete design control, which is a big thing. And I keep saying to clinicians, the key thing here is if you're investing your hard-earned money in technology that's going to that you're basically investing in your clinic and you're investing to reduce your overall costs and improve profits, well, you have to be willing to take the time to learn how to use the technology and understand the technology. So it's investment in cash and investment in time initially to learn all this.
Oh, definitely. It was no different when we had the milling machine. Yeah, we had the milling machine installed,
Yeah.
but I wanted to know how to do the design part. So a patient could come in, we could do the scans, we could do the design, we could get it milled, we could finish the product off and do that process really fast. So what do you prefer when you install a printer into somebody's clinic? Do you
Yeah.
prefer them to learn how to do the CAD design as well? Or do you prefer to do the designs for them? Or they just have a choice?
Do you know what? It comes down to really business. And,
Yeah.
and when I say business, it comes down to what makes business sense for a clinician. Because the design a set of orthotics, when you get used to CAD design, can take you 10 or 15 minutes. But what I look at is, could you have a nail surgery done in that period of time where you might earn, I don't know, £200 or £300?
Yeah.
So you can save maybe £20 on a CAD design and cost yourself maybe £200 or £300. So we give the options to clinicians what they would like to do. If you want the full process where you have full control, you scan, you design yourself, and you print yourself, you have that option. You can also send the scans to us as a laboratory, and we can design and send you back the file. So all you have to do is put it in the printer. And in a lot of cases, when that happens, it's the admin team or the receptionist that's dropping the file onto the printer. So it's not timing up the time of a busy practitioner.
The
So
podiatrist focuses on being a podiatrist, seeing the patients, doing the evaluations, filling in the script on what's required, and then moving on to the next patient, and then just letting that orthotic process happen with other people.
yeah, that's it. And as a matter of fact, I was speaking to a practitioner last night. He has purchased 2 printers off us over the last 12 months. And he used to be a lab owner, and I believe he was on your podcast some time ago, Clifton Bradley from Sub 4.
Oh, yeah. Yeah.
And yeah, and he mentioned to me, he said, Kieran, he said, since I put this in here, he said, the cost saving is massive. Because he said the biggest problem when I had my lab was the cost of staff, the continuous turnover of staff in finishing the orthotics.
Yep.
And he said, when I sold off my lab and I went back into the clinical side, which I think he always did clinical side anyway, he said the big thing I was looking at is what I was paying on lab fees. So he said, by putting in the actual printers, instead of paying lab fees of maybe 120 to £150 for a pair of orthotics, he said, I can literally print my orthotics for about £5 and £6. So
Yeah.
sometimes what he'll do is he'll send us the designs if he's busy and we'll design the orthotics. So his cost is slightly higher, but he's still a good 70 to 80% saving on what he was paying the lab. Plus the turnaround is a lot quicker.
I can see it from both sides. I think it'd be great to know how to do the CAD design yourself, because you may get that patient that's come in, you need to do something urgently and you want to get it done and get it out. And then at other times, I can see the benefits of be seeing the biomechanical patients, doing the evaluations, and let somebody else do the design. So how much, can I ask, how much is the lab fee if you're doing the design?
Yeah, if we were doing this design for someone, we charge £25 plus VAT. So you're looking at your cost of production is about maybe £35 in total to print your orthotics.
Okay.
Now, if you design yourself and print it yourself, you're looking at your cost is going to be somewhere around £10 to £12. So
Okay.
it's a trade-off depending on what you can be treating in that time. That's what I'm saying. If you were doing a nail surgery in the time it takes you to design an orthotic, you have to work out which is going to be more viable for your business. So
You were working that out like in Australian dollars, it's like $70 to get a pair done if you were doing the whole thing for them. And that's including the cost of them printing it as well.
Yeah, that's it. So, but I do agree with you, Tyson. It's good to understand how to design.
I think
And I
so.
think by understanding how to design, I think makes practitioners also more aware of what the importance of doing the proper tests and checks are. So when you're looking at maybe your classical flat foot, well, why is it important to check to see if it's a rigid flat foot versus flexible? Because I've seen it from time to time come into the lab where you have a scanner recast of a flat foot and it hasn't been put down if it's a rigid or flexible flat foot. So as you know from previously running the lab, you don't know what to do. Do I put in an arch support? Don't put in an arch support.
Yeah,
So I think often having the exposure to the CAD design makes you think more deeply and you can see more clearly why I need to do all the tests and checks. So I
yeah,
think it's a good thing to do. The other thing that I think is quite important as well with the advancement of technology and the materials that are coming along, and especially with 3D printing, the way you can change infill density. So you can make your orthotic and change the density anywhere in that orthotic. So you can obviously influence, let it be pronatory forces or supinatory forces with infill. I think it's very important then to understand the different infill densities and what works best for maybe certain body weights. And I think education needs to be created all around that side. So practitioners would know what to order because you order an orthotic or go to design an orthotic in your clinic. You say, I want a soft orthotic or semi-flexible. Well, that's your impression
yeah,
of what's semi-flexible. Mine might be different. Whereas with 3D printing, you can print off samples and you can say this is a 20% guy ride, a 10% guy ride. So you can feel it and then you can order based on the actual percentage that's in front of you. But I think it's having that knowledge, I think, would be key as well. And I think we're very much still, in a way, at the start of the journey. Our software and our printing has advanced. We have it grown out to clinics as far as Dubai and places, and it's been working really well. But I think when I say we're at the beginning of the journey, I think the education around what's needed from clinicians to understand the whole process and to get the best from it, I think is at the beginning.
you're going to be at the Foot and Ankle Show again, 2026.
Yes, we're there, yeah.
Yep. And I know when I looked at it, 2025, and I thought your setup was great. And you had one being printed there, and you're explaining how it does the different densities and what it can do. And I was super impressed with it. It was very slick.
Yeah, in the software now we have even advanced it further, Tyson. We've been taking feedback from clinics. As I said earlier on, every clinic has preferences.
Yeah.
So the big discussion started occurring around weight-bearing scans versus non-weight bearing scans. And as we were talking, the practitioner said, often our pet hate with orthotic laboratories is you order an orthosis, you order a met dome, the met dome is put on, and you order a repeat, and the met dome comes in the wrong position.
Yeah.
And they said this is often a major issue from. And the same maybe with sinks or Dell cutouts. So what we looked at is harnessing the power of two technologies. So now you can take a scan, let it be using your iPhone or your iPad, or you can use a weight-bearing 3D scanner, whichever one you want to use. But also, if you have pressure pad technology or in-shoe sensors, we can take the data from these pressure force plates, overlay it on your orthosis, and where the peak forces are of the red pressures, we can automatically place met domes or accommodations or sinks. So that then is giving you a more accurate design. So you have your orthotic and your arch values got from the 3D scan, and then you're taking the pressure mapping from the weight bearing. So I think with 3D printing, it's allowing us really to push boundaries. So we're harnessing power, and it's not a case that you have to have a specialized pressure pad. It'll work with the majority of them. You're just
Okay.
taking the data in off it. So the clinics don't have to go to major expense. But the journey that we are on at the moment is footwear even. So since you've seen us,
Yeah, I
we've
think you
gone
were
down to
designing. Were you printing out a like a football boot at the
yeah,
field
what we
show?
have done, yeah, what we have done now is we've been testing different types of footwear. So we've built into our software that you have the ability to do 3D printed sandal bases, 3D printed slider flip-flops, which is including the strap. So
Yeah.
it'll print as one unit. We've also done running spikes, and we've done what we changed the brand name. You might be familiar with the Croc type of shoe.
Yeah.
So we call them gate airs basically. So we've been trialing them as well and printing them. And the thing is, it's learning how to position them in the bed that you print them with minimum to no supports if you can. So you reduce the supports that you're printing, because when you put supports on to build a structure out of TPU, they're quite difficult to remove. So we've been testing how to get around that, and we've been looking at the whole area of water-soluble supports. So you're printing basically with two materials, your support structures, which is the scaffolding in water-soluble, and then your footwear in actual TPU. And you
Yeah.
just drop it in a bucket of water afterwards and your supports are gone. So it leaves for cleaner finish. So that's the kind of stuff we're working on currently.
Okay, I've got some questions though before we go any further.
Sure.
One, because these are going to be questions that people are going to be thinking about. And these are some of the questions, some of my coaching clients who some have got 3D printers and some are thinking about it. If someone wanted to get a second pair designed, once you've done the design for the first pair, do they need to pay again to get another pair done? Or once they've got the design, they can pump out as many as they want?
Yeah, when you have the design, you can pump out as many as you want because your
Okay.
design is saved on, you can save it in the pen drive or on your actual printer itself. So you
That's
can
good.
keep it out.
That's a big
Yeah,
tick. It's a
it's a
big
massive
tick
thing.
for
Yeah.
fit for. The cost of the printer, how much are the printer costs at the moment?
Well, the printer is part of a package. So what we found is you had to put a package of service and training involved. So there's cost of everything and education.
Yeah.
So if I was explaining the package here in the UK, the package would be your printer, would be an education course around biomechanics that goes out with it. The
Yep.
course itself is worth about £600. Then our engineers deliver the printer on site, set up the printer and give you a day's training on site, then give you an additional training day at the lab if you want to, and then training on the CAD softwares and things. So that entire package here in the UK works out at 9,800, including the printer and full warranty. Now, we set systems up out in Dubai as well. So I'm literally just back from a trip to Dubai.
Yeah.
And when we set up out in Dubai, we travel out there and set it up because to me, you can buy a printer, it can come in a box, and you can try and weed your way through trying to set it up and get it going. Sometimes you might do it quite easy, other times you might, and might not if you're not familiar. So we thought, let's remove the headache from it. So that's why we do it. But a practitioner has the option if they just want to take the printer from us. So we're looking at the printer price as just a printer and so on, where we can ship it to you would be somewhere just around maybe the 5,000, 5,500.
Do you know that
That's
is
what we're
cheap?
looking at. Yeah, it's very reasonable. But I
It's
said,
very reasonable.
to me, I would definitely say you need the support package
I think so.
because everything is great until something goes wrong. And it does go wrong. There's no machine out there that is flawless. And if you're not familiar with it, you can have the biggest headache going. So it's
Yeah.
often easier to look, have an engineer come on site, set it up, give me the proper training so we know everything's working perfect. And with that hand to hold training, it spares you the headaches. And it
Well,
means, yeah,
it's one of those things. It's like when we had our walking platform set up, when we had different treadmills set up, when we got the milling machine set up. Every time we had someone come on, set it all up, make sure it was all working perfectly, spent the money and the time doing the training, and it was flawless. So
yeah.
I think this is probably the best way of doing it is taking that package and making sure it's all up and running. Like I just recently got myself the iPhone 17.
Yeah.
Picked it up and I got the thing and the person said to me, hey, do you want to just set it all up here while you're in the shop with your watch and everything else while we're here? And I went, so I'm in a bit of a hurry. I've got to go. I will just do it at home.
Yeah.
You always know when something is going to play up a little bit. And I've got everything working perfectly on it, except I still can't get the thing to connect to my watch. If I had been in the store and did it right there and then with the people, I'm sure everything would have worked perfectly.
That's it. It saves the headaches.
Because it'll be something really simple that I'm doing wrong, or my watch could just be buggered.
Yeah, Tyson, that's it. I mean, we've come across that where we'll go into a clinic and we'll set up the systems and the practitioners don't have the headache.
Yeah.
Whereas what we've often come across before is someone might buy a piece of software over the internet, a slicing software to try and hook up with the printer. And next thing you find is they don't know how to rig it up to the printer. So they end up with headaches. And eventually they end up calling us after they've frustrated themselves. So you can avoid the frustration. And the way I look at it, the time you spend trying to figure out how to do things is a loss of revenue where you could be running your business and on with patients. So it's often wise to say, I'll make the investment to make sure everything is set up and it is flawless in what it's doing because you're paying to get rid of headaches. And we have taken the stress and headaches since 2019 with the research and development we've been doing to save that stress for the practitioners.
But it makes so much sense to actually do that. And I do. Oh, and the other question I had written down before I forget was
Yeah.
turnaround time. So I do a scan in my clinic. I send it off to you because you're going to do the design. How long does it take before the design comes back?
What we do is a maximum of 3 days.
Okay.
We do a maximum of 3 days. And the reason why we do a max of 3 days is there's quite a large volume that come in because we have NHS hospitals that have taken on the printers as a cost saving. And I suppose the biggest thing for hospitals is trying to meet net zero for 2035. So the materials sit with that in 3D printing. So when you're getting large volumes in, we say a maximum of 3 days, but in a lot of cases, we have it back in 48 hours. But we say 3 days just to kind of give comfort because you know yourself, if you say one day and you're 2 days, you have complaints.
Yeah, I
Whereas if
know.
you go
Yeah.
slightly longer than time and you bring it in early, people thank you for it.
Yeah. Under promise and over deliver.
Yeah, that's
It's,
it. Yeah.
yeah, because the reason people might be listening to this and they might be thinking, wow, this is a real plug for your particular company, which it is. And like I said, you're not
Yeah.
paying me to be on here. I asked you to come on. The reason
Yeah.
I asked you to come on, one, because I know you and I think you're a good guy. I saw your equipment when I was at the Foot and Ankle Show, and I'm looking forward to checking it out even further when I'm there this year. But it's also one of these things, I really believe this is where podiatry is headed in the future, where one day I can see in the future, most clinics are going to have a 3D printer. And so I think this is what the conversation needs to be heading this way. And people need to be taking more control and speeding up the process of getting orthotics made. This making patients wait 7 days, 2 weeks for orthotics, I still think is just crazy.
Yeah. To be honest with you, Tyson, we've seen the change. Like over here in the UK, we've seen a few orthotic laboratories close down over the last 12 months due
Yeah,
to rising costs. Rising costs, staff issues, it's horrendous. And it means the price of the orthotic is going up. So the clinician is not making the margins they need to in a lot of cases. So if you're not making the margins, is it worth having the stress if you're dealing with things? So the 3D printing is definitely changing that. We have a traditional lab as well, which we have run.
okay.
And we've seen ourselves in the last, I would say, 2 to 3 years, through a transition that we have definitely gone to about 60% of clinicians are gone across to 3D printing. And we've seen that every month we're putting out a few 3D printers every month without fail. So what we'll do is we'll put out the printers, but when we put them out, we always deliver them to do the training to make sure people are comfortable if they want that side of things
Yeah.
done. What we're looking at is we see the growth, and with the feedback we're getting now from the clinics is great because I had one clinic say to me, he said, on lab fees alone in 1 year, he said, I saved £25,000. Now
Oh,
that's quite a saving.
yeah. I know when we got our milling machines set up, we were doing at the time over 1,000 pairs of orthotics a year.
Yeah,
And instead of paying a lab fee of $100, $120 at the time, it was costing me like $20 to get it made with the materials.
yeah.
So I was saving $100,000 a year easily by having the milling machine on site.
Yeah, absolutely. And what I see, Tyson, as well, to be honest with you, we're looking at, I think, in the whole field of biomechanics with clinics, because we've been chatting to clinics quite a bit. And what we find is a big thing that there's two areas that we find is some clinics are really experts when it comes to bespoke orthotics.
Yeah.
You have other clinics like more simple solutions such as your prefabs. And I think the gap is starting to close now because more and more clinics are going in from the prefabs, updating their knowledge and starting to go more towards the prescription. But I also think as you have younger podiatrists graduating out of universities, they're going to adapt to technology, I think, at a kind of a quicker pace because they're embracing technology, they're come up with technology. So I think podiatry will go the full circle. Like years ago, you saw your patient, you took the cast, you produced the orthotic yourself, you fitted it, and if you needed to modify it, you could do it. And I think 3D printing is bringing it back in that full circle. And the big thing with 3D printing is if you do need to modify an orthotic, it doesn't cost you the world
Yeah.
because you know your production cost is potentially, if you need to reproduce, maybe 10 or 12 pounds. So you can modify and adjust that orthotic quite easily. Now, in the software that we have, we built our software into as a plugin into Rhino. Now, Rhino, when you research Rhino, Rhino is a very powerful CAD software. So Rhino was originally developed by McNeil in US. And McNeil in the US were shipbuilders. So it designed this software is capable of designing ships.
Okay.
Everything from the engine to the hulls, the whole lot is designed. So it was great with curved geometries. And a lot of companies such as jewelry manufacturers, footwear manufacturers, then build their software within that. So they're harnessing the power of it. Now that's what we did as well. But what makes it lovely is if you have a modification to do, you can save a file when you design this as a 3DM file and also export it as an STL. So the STL goes in your printer, the 3DM is there, then you can modify it without putting yourself into any major time or cost. So there's nice backup with it. So it's
Yeah.
brilliant in that respect.
What you said before about doing that full circle, I have to agree with you. That is what is basically happening. Because I do. I remember, yeah, when I first graduated, 1988, seems so long ago. And you do the plaster cast. And there were a lot of podiatrists that were making, there weren't a lot of orthotic labs around. And we were
Yeah,
all taught how to make orthotics. But as time went on and people got busier, because of time, they then sent it off to a lab to do.
yeah.
I used to do my own by hand until we got to about 70 or 80 pairs a month that I was making by hand after hours. And I went, this is getting crazy. Then
Yeah.
used a lab and then circled back around to the milling machine. If I still had a podiatry clinic now, I would have a 3D printer. I wouldn't even be thinking about it.
Yeah, because the 3D printer is to work away, and the beautiful side of it as well. From a business point of view, positioning a 3D printer out in your waiting room gets new patients talking about what's going on.
Oh
Because I've
yeah.
seen it when we go to trade shows, go to a trade show or go to a clinic where there's a 3D printer. First thing that happens is people start recording it.
Yeah.
So when you're in a clinic and you have patients recording this and maybe sharing it to social media, it's getting interest going within your clinic. And it also means those patients that may not have come in for orthosis are now thinking of orthosis and will potentially speak to the podiatrist. So it's opening up more avenues. And the thing is, the printers are safe to run out in the waiting area because the doors and everything are lockable, so that no one can access it. But it just runs away quietly out there because there's no noise. It's not like a milling machine where you have this
Oh,
continuous humming. These things are pretty much close to silent. So
yeah.
it's quite
It's one of my coaching clients. He set it up in his reception area. And he said, one, it's better than a fish tank.
absolutely.
His orthotic numbers have dramatically increased because he has the 3D printer there. And
Yeah,
I shot a video on this because when I was in Seattle, there were so many businesses over there that just did so many things to capture people's attention, from throwing fish to making frozen yogurt in front of everybody. You could see it in the back area. There was a cheese factory making cheese and then selling it. And I went, podiatrists can learn from this. What can you do in your clinic that's visually appealing? That when people film stuff, what do they do with it? They share it online and people
yeah,
start talking about it. So that's where 3D printers, I think, are going to be a huge advantage to certain podiatry clinics. And I say, be first. Don't wait till somebody else in your town gets one. Be the first person to get one and then let the rest follow you.
yeah, absolutely. We've seen that we have a number of podiatrists over here that have took it on with early adapters.
Yeah.
And as early adapters, what's happening is, I suppose you gain the respect of fellow practitioners because they're looking up to you. And what you find is podiatrists contact podiatrists for advice because they go to a company, think, I'm talking to a salesperson.
Yeah.
Whereas they like to take advice from fellow podiatrists. And what's your experience? Give me the good, the bad, the whole lot, so I can see if it's something that is going to fit in for me. And that's the way it's grown at the moment. And the early adapters of the actual system that we were working with quite closely, they've been fantastic because they've been helping to educate fellow podiatrists as well, going through what's important from the point of view of the checks of the patient, the way they think differently, maybe in how to prescribe an orthotic. So they're sharing their experiences, and that knowledge base is starting to grow.
Mm.
And that is, I think it's very good for the profession, but it's very good overall for every podiatrist because shared knowledge is a big thing.
Oh,
We all learn
definitely.
every day. Yeah.
Definitely. So you've got, obviously you got printers through the UK, you got them in Dubai. Have you got any in any other countries? Australia,
Yeah,
US,
we have
Canada?
Yeah, we have printers currently at the moment. We have them in Singapore.
Yep.
We have some printers going out to the US. We have printers in Dubai and Doha. We have printers in Ireland and in the UK. And originally, you see, what we were trying to do, Tyson, is treat it like simply a bicycle wheel. So we said if we start off locally,
Yeah.
we can learn from this. If there's any problems, it's easy manage.
Oh, yeah.
So we only started putting them out overseas in kind of the last 12 months when we knew we were on top of things and that we could give proper support. Because
Mm.
what we didn't want to do is make a stick for our own back, that you put something out there, especially with social media. If you
Ah,
don't do justice and with service, you can be destroyed. So we decided, look, let's keep it local, let's manage it well, and let's grow it slowly and under control. But now we're pretty confident that we have it nailed and it's running quite well. And as I said, the biggest part of all this is often the podiatrist understanding what their role in this is.
yeah.
Because if we break it into little chunks, the printer prints the orthotic, but it takes instruction from the CAD software. The CAD software is taking instruction from the podiatrist. So it's all starting with the podiatrist, and the finished orthotic is the result of what the podiatrist decides. So a 3D printer like the milling machines you had, they can produce the most accurate piece of garbage
Oh, yeah.
that you can imagine if you put in bad instructions. So you
Definitely.
need to understand your role from start to finish. So that's the kind of chain that we see working with it.
No, and that's why when you're talking about the package and the biomechanical education behind the scenes, because there's going to be some podiatrists that their biomechanical knowledge is fantastic, but there's going to be other ones who it may be lacking in some areas. So I think it's good that you do have that training in place.
Yeah, absolutely. But the other side as well, you see, it's not even just on your biomechanics of how you assess the patient. It's a few practitioners said to us that they have started thinking differently with what you can do to a 3D printed orthotic to achieve a result and keep a bulk of an orthotic down by
Yeah.
just the patterns. So I suppose some of these clinicians over the last couple of years, what they've done is they've done their own clinical trials in a way, and they found out what's been working really well. So that knowledge from maybe very much experienced podiatrists that are specialists in biomechanics is a big help as well to pass on knowledge to fellow podiatrists to say, this is what I found worked well, maybe for posterior tib tendon. I achieved it by doing this with the infill and it worked exceptionally well. So it's that kind of knowledge is also invaluable. And that's where we have hooked up with podiatrists that have been using our technology for a long time, that are very much experienced in biomechanics, that are doing it. And as a matter of fact, I was even the chap I was speaking to last night. He mentioned that he runs basic biomechanic course at the moment.
Yeah.
And he said, my train of thought has changed. And he said, I'm thinking of how I can even teach my courses different to encompass what 3D printing is capable of doing. So everyone is starting to change their mindset of how they design the orthotic and how they can get a better outcome and how they can reduce bulk. That is what I can see is happening now.
Especially the bulky side of things. I know when we were milling it out, because it's EVA,
Mm.
it was always a little bulkier than if you were doing something at a polypropylene. But I like what you're talking about, where the podiatrists that are using this equipment, they're almost doing their own in-house research, and then they're bringing
Yeah.
that information back to you. But now you've got all these collective minds together, which are in the end going to produce an even better result or a better
Yeah, that's
product.
it. Yeah, that's it. And that's what's happening. That's where we've built the software. So in the printers currently at the moment, we can print TPU orthotics. Then we had, but as you said to us, we'd like to be able to print polypropylene shells like your traditional shells.
Yeah.
So we built that into the software to be able to do the shells. We had other practitioners then said to us, look, I don't want to be able to do the carbon rocker plates. So if you're treating turf toe or something, so
Yeah.
we added that into the software so you can print your carbon rocker plates and things. So it's continuously evolving. And I think the thing with the software is software, the minute you stop developing, it becomes obsolete. So you're
Oh,
listening to the
true.
market all the time and saying, what else can be developed? So the next thing we're working on is AFOs. So there's no reason why the AFOs cannot be 3D printed. Now we have done some test prints of AFOs, but we're looking at that you could get maybe a far superior bespoke AFO from 3D printing it. Because if you take a digital scan of the lower leg
Yeah.
and you take the dimensions of that leg nice and snug from the width of the calf coming down to the ankle, your brace that's going around the leg is going to fit much better rather than something that's a bit more generic in the foot base is custom, have the whole lot custom. So we're looking at the moment of building that into our software, and we're liaising with podiatrists on what they want and also with orthotists. So we're getting feedback on that continuously.
So I can see how excited you get about this. Your background is mechanical engineering.
Engineering, yeah. What I did was mechanical engineering and I did sports science. I
Yeah.
did sports science where I got the biomechanics, but I've worked in the area of orthotics for the last 30 something years. So another thing we have done, and this was designed in the software as well. This was sitting on a plane going to China. I mentioned to you earlier on, Tyson, that there's two very much areas that we see in the whole area. You have the prefab type of orthotic and you have the actual full bespoke. Now, in our CAD software, you can design pretty much anything. So my wife is studying podiatry at the moment. She's in her second year in Northampton University.
Okay.
Kids are grown up and she decided to go back and do things.
Never too old.
Yeah, she's enjoying it. And we were sitting on the plane, she was getting ready for her exams. So I was a little bit bored with no one to speak to. So I opened the CAD software and decided to draw up a prefab. I got an idea for a prefab orthotic.
Yeah.
So this is the power that you can do inside the CAD software. So this is the device I drew up. So this device is shell format here.
Yep.
That has a little bit of flexibility in it.
So I'll just point out to people who are listening to the podcast, because we're shooting this as a video, Kieran is waving an orthotic around at the moment and explaining everything. So if you're listening, just keep listening. If you're watching the video, then you know what we're talking about. So keep going.
Yeah. So what we did with this is I was looking at an orthotic that was simple that you could do correction. So this area here in the heel is a disc. And this disc can be flipped and rotated. So you can get varus and valgus posting.
Okay.
So if you want a 6-degree varus or valgus, you just flip it into the direction. Flip it backwards, you have a heel raise of 2 mils or 3 mils or whatever. And then here in the forefoot, these segments that are numbered under each mat, they're in with Velcro. They can be removed to create offloaders. So that's something simple. But that is the power that the CAD softwares give you. You can draw up anything. So I thought, this is something simple that I could draw up and meet maybe needs of clinics with their basic needs of prefabs. So we haven't launched that yet. I've been just wearing my own shoe.
So that wasn't done through 3D printing, though, was it?
Yeah, that was something that was done. That was something that was done in our CAD software, but I originally 3D printed it to test it.
Oh, right, okay.
So I originally 3D printed it to test it because before we went off to build injection molds and things to mass produce it, I wanted to see that the disc and everything was going to work in it.
So that's the insole that you're going to launch in the not too distant future.
Yeah, we're going to launch it maybe in February time. So February we're planning it, and the idea is to keep it low cost device. But what I was trying to bring across is when you understand the power of CAD designing, that's the point I was bringing across. In our CAD software, you can draft up anything you're looking to do. You just need to understand what you're about. And that's the power of kind of the FitView plugin within Rhino. You have that power to draw anything. So that is done on the plane to China. And we're going out putting out other technologies.
Oh, well, I'll see it. You'll have it at the Foot and Ankle Show. Yeah,
we're planning to bring it to the Foot and Ankle Show to show that with the 3D printing things, because our idea is to show the full capability.
Yeah.
That we have behind it as well, and that we have to be upfront is that practitioners, if they're thinking of making an investment in any of this type of technology, the thing that they need to be prepared to do is to invest the time to learn and often to refresh the biomechanics, the whole lot, so you have the package. Because if you don't have the front part, the rest is going to be a lot more difficult to do.
No, I like right from the start, everything you've said, I agree with. That I think having that package idea and the training behind it, because I do have another coaching client who was looking at 3D printers, and she was given a couple like on loan, and they were just dogs. They were just, and the company that were trying to work with her, she couldn't get hold of them. She'd send designs off, and the thing that came back was completely wrong. If something needed to get remade, they would say, no, you got to pay a whole new fee again. And she's explaining all this to me, and I go, oh, no, there has to be better companies out there. So he's pretty much given them the flick and now on search for something else. And I said, well, I know someone, because I was talking about what you were doing, and I know some other companies around the place as well. But when I saw you at the Foot and Ankle Show and I saw your unit, I also thought everything you were doing was actually price-wise was extremely good.
Yeah, we decided to keep it sensible, because we do know we could have charged a lot more. We know we could have charged 30, 40,000 for the package. But we said if you keep it affordable for clinics, they can get the return on investment quite quickly.
Yeah.
But the other thing I was looking at, Tyson, that we were looking at for other countries that we could see could work quite well is maybe a concept that we were kind of coming up with, like micro labs.
Oh,
That
yeah.
if you had one clinician that's our clinic that's expert in biomechanics, and they could become a hub for clinics around them.
Yeah.
And we could see something like that could work quite well, where you get a quicker turnaround time in your orthotics, and you're dealing with someone that you know locally, and you know the knowledge, and you understand each other quite well. Because what I've found is often between laboratories, and I'm sure you came across it, labs change the names of materials to make a material often sound more high tech and to
Yeah.
get more sales. And it's often just the same material with different names put in it and different price points. That then causes confusion for practitioners because they often don't know what the hell they're bloody ordering. So I often find if you have, we're thinking like your micro kind of lab situation, because we were thinking this could work in other countries quite well, that you train a little group of people, they set up the regional little labs around the place, and they provide service to other clinics. That way then there's no real clinics competing with each other. You're working in unison because there's a market big enough for everyone. And at least you know, well, that podiatrist down the road is an expert in biomechanics. They've been, let it be, presenting in biomechanics for years. I'm comfortable with their knowledge. I understand the way they work. So I could team up with them and let them produce. So we saw the idea of microlabs could certainly work in different areas. And
Yeah.
from our point of view, it's something that's very easy to support.
Yeah. I think in
So
different
it's,
countries that would work quite well because having local people that are closer. There, for some reason, there is a problem that they can get on the phone, ring up, and then somebody could be there in a short period. Someone that can hold their hand. They've got that local support, I think is important.
yeah, and that's something that we're doing at the moment out in Doha. So we flew to Doha a couple of weeks ago, and we were working with a team of clinicians out there. And it's a company that kind of has multiple sites around Dubai and that. So we set up on one, we're spending time training the clinicians there. Then what we're doing is we're online then working with them on teaching them the CAD softwares.
Yeah.
So we did this, set up the software, everything working. Now it's a case of over the next number of weeks, as they're starting to fit patients with orthotics, we're helping them with getting familiar with the CAD designing. So one of our engineers and designers will sit with their team and they'll say, this is what we want to put into the prescription. So they're sharing screen and working together. So what our practitioner will do, they'll do, and they're mirroring in each other. So you're getting familiar with how to do things. So that's the way we're working with support. And that is something that can be mirrored in any country. We've done it in Singapore, we've done it in other places, and it works exceptionally well. The only thing that we look at then is, you see, is the mindset of podiatrists and medical practitioners can slightly vary on
Yeah.
preferences. So if you go to Germany, I know EVA is the most popular material for orthosis. Whereas in the UK, it hasn't been. It has been more kind of your polyprops and things.
Yeah.
So different countries have different little ways. And if you have the microlabs run by a practitioner that understands that local market and the mindset of the practitioners there, I think it works much better.
No, I definitely agree. So if anybody wanted to reach out to you or ask you more questions, or they might want to invite you on their podcast, what's the best way of getting hold of you? What's your best contact?
You
Your
can
email
just
address.
email or just call us. Yeah, email or
Yep.
call us. Yeah.
What's your email?
So the email is Kieran at foothealthorthotics.co.uk.
Okay. Nice and simple. And the website?
And the website is obviously www.foothealthorthotics.co.uk.
Okay.
So
I will put that.
the original
I'll put
company
that
name.
all in the show notes for anyone who found Kieran's accent a little difficult sometimes. I will have show notes with a lot of this information in there.
Yeah, often need a subtitle for the Irish accent.
Oh, sometimes there were some of the companies you were mentioning earlier on, and I'm going, no, I didn't quite hear that, but I'll be able to hunt it down and I'll put it in the show notes and get it all sorted out.
Yeah. But what we'll do, Tyson, is I'll send you the contact information for our business.
Yeah, that'd be
If
great.
anyone wants to reach out to us. So I'll send you an email afterwards. So you have all the contact information if you do want to share it and things.
Oh, yeah, no,
And
I'll definitely have it all in the show notes. Anyone listening to this, go to podiatrylegends.com, find this episode, and all the information will be there. So, Kieran, I want to thank you for coming on the Podiatry Legends podcast, sharing what you've been doing with 3D printing. Like I said, I think this is the way of the future for podiatry. And look forward to having you back on at some stage. Keep us updated.
Tyson, thank you very much for your time, and I look forward to seeing you in February.
Oh yes, I'll see you. Was it beginning of March?
Will be beginning of March, 3rd of March, isn't it?
Yes. Yeah, okay. Yeah. I will see you there.
See you there, Tyson. Thank you very much for your time.
So before I wrap up today's episode, I want to take this moment to reflect on what Kieran and I have really been talking about here, because this conversation goes far beyond 3D printers and orthotics. At its core, it's about control over turnaround times, control over quality, and control over costs, and ultimately control over how you run your podiatry business. Over the years, I've seen clinics become increasingly dependent on external labs, longer wait times, and increasing lab fees. What struck me about this conversation is that 3D printing isn't just a technological shift, it's really a mindset shift. It's podiatrists bringing the process back in-house, supported by education, systems, and smarter workflows. Now, that doesn't mean everyone needs to rush out tomorrow and buy a 3D printer, but it does mean asking better questions. Where are my margins really going? And what is slowing down my clinic? And what systems do I rely on that I don't fully control? Are there things that are happening externally from your practice, like other labs, that are out of your control, and you need to bring that back in-house? And if this episode has sparked a few of those questions for you, that's a good thing. This is exactly the kind of conversation I have with podiatrists through my business coaching and mentoring work. Not telling you what you should do, but helping you step back, look at your clinic objectively, and decide what makes sense for your business, your patients, and your lifestyle. If you're at that point where you're thinking about systems, maybe scalability, margins, or simply just running a calmer, more profitable clinic, you're very welcome to reach out to me. No pressure, no pitch, just a conversation to see if coaching is the right next step for you. You'll find all my details at tysonfranklin.com. And as always, all the links from today's episode are in the show notes at podiatrylegends.com. So before I finish up, I just want to thank you for listening and supporting this podcast. I want you to look after yourself, look after your family, and I will talk to you again next week. Bye for now.